Hi, I'm Cassie, and I'm going to walk you through question 8, which is related to passage 2 of the AAMC official MCAT physics question pack. So question 8 asks about what's going on at the point where our three curves intersect for the second time in figure 1a. And then our answer choices outline 4 concepts that you need to understand to be able to answer this question and future MCAT questions related to this topic too. We need to understand what it means to be in phase versus out of phase for a wave, and what it means to have zero displacement versus max displacement for a wave. So our figure looks something like this. Essentially, the second point where all 3 of our curves intersect is going to be on the x-axis here. So first, let's talk about what it means for waves to be in phase. So if we take a look at our black and our red wave here, notice that they're exactly lined up. And what do I mean by that? I mean that the peak of our black wave here is aligned with the peak of our red wave, and the trough or the low point of our black wave here is aligned with the trough of our red wave. So we say that our waves are in phase when our peaks and our troughs line up like that. And what happens then, of course, is that we get constructive interference, where the amplitude of our 2 waves is going to add together to create a resultant wave that has the combined amplitude of our 2 waves. Remember, the amplitude of the wave is just its displacement from the x-axis. So for our black wave here, its amplitude would be here. And for our red wave here, it would have an amplitude of this much. So when we're at the peak of our wave, like we're at the peak here of our red wave and the peak of our black wave here, we're at our max displacement point from the x-axis. Versus when our curves cross the x-axis, like happens here, they're at their point of minimum displacement from the x-axis. There's literally no displacement, right? They're on top of the x-axis. Now let's look at an example where our waves are out of phase. So notice what's different about the alignment of our waves here. Our black wave, its peak is at where the trough of the red wave is. Okay, and the same thing here, right? The peak of our red wave is where the trough of our black wave is. So in other words, our waves are out of phase. They're not lined up. And the result of this is going to be that the positive amplitude of the black wave is going to cancel out with the negative amplitude of the red wave. And you're just going to get a resultant wave that has zero displacement, or is, just in other words, like a line along the x-axis. You're not going to get any signal. Now let's take a look back at our original figure and see what's going on at that point. We said that our 3 curves, they cross for the second time at this point here. Now you should immediately be able to tell that all 3 of our curves are at a point of zero displacement from the x-axis because they're literally all crossing the x-axis. So you should be able to quickly pick out that the answer to this question is zero displacement. Now, where I see a lot of students get confused is they understand that the 3 curves at this point have zero displacement. What they don't understand is they think that the curves are also out of phase. But if you take a very, very careful look at the figure that the AAMC gives you, notice that it's not so clear whether the 3 curves are out of phase or in phase. On our first curve, with our lowest frequency here, this big guy, the intersection point here seems to happen at the point where we've reached the peak, right? And then we're about halfway down our wave cycle. Now let's take a look at one of our other curves here, our small dashed line. Looking at the intersection point here for the small dashed line, it looks like it's almost potentially at the same or very similar phase in its wave cycle, right? We reached the peak and now we're on our way back down again. So again, it's not super clear, but those 2 waves, they might even be in phase. Hard to tell. And then if we take a look at our final curve, the bigger dashed line, notice that our intersection point here seems to be at the point where we're going up towards the peak of the curve. So that seems like it would be out of phase. It's not in alignment with the 2 other waves. In other words, to wrap up, if you closely analyze the figure, it looks like 2 of the curves might be in phase and the 3rd curve might be out of phase, but it's not exactly clear. So the MCAT is always going to give you a very clear answer. In this case, the answer is that it's very clear all 3 of the curves are at zero displacement. If you're not sure about an answer, it's not the right answer. So that's why we're going to eliminate the answer out of phase for this question. I hope this helps. If you have any questions, drop a comment and please subscribe if you want more content like this to help you ace the MCAT.